In fact, interdomain routing can oscillate indefinitely. To see why, consider the following 4AS topology, where each AS specifies preferred paths, presumably via local preference. So each AS prefers the AS in the clockwise direction rather than the shorter direct path. Now it's pretty easy to see that there's no stable solution. Let's suppose that we started off with everybody selecting the direct path. Well, in this case, any one of these ASs would notice that it has a more preferred path. So for example, AS1 would see that because AS3 has picked the direct path, then in fact it could prefer 130. Now we enter into a situation where oscillations can occur indefinitely. Similarly, here now AS3 sees that it has a more preferred path, 320, so it might switch to that. In doing so, it breaks AS1's path. 130 no longer works, so AS1 has to switch back to its less preferred direct path. But now we're in the same situation all over again, because now AS2's preferred path becomes available via 1. So AS2 now reroutes, and AS3's most preferred path, 320, no longer works, so it must switch to the direct path. Now it's very easy to see that this oscillation continues ad infinitum. This particular pathology was first discovered by Varadhan, Govindan, and Estrin in a paper called Persistent Route Oscillations in Interdomain Routing in 1996. Later, Tim Griffin formalized this pathology and derived conditions for stability. Those stability conditions came to be known as a BGP correctness property called safety. It turns out that if ASs follow the ranking and export rules that we discussed, that safety is guaranteed. But there are various times when those rules are violated. Business relationships such as regional peering and paid peering can occasionally cause those conditions to be violated. So as it turns out, to this day, BGP is not guaranteed to be stable in practice, and many common practices result in the potential for this type of oscillation to occur.